All right, guys, here we are with our last video for the chapter. We have flown through the first chapter. We are on section 1.4, definitions of trig functions. This chart up here kind of describes the fact that sine and cosecant are reciprocals. So these are called reciprocal identities, and they're still the same pairs that we've been talking about the 6 trig functions in lessons before. This chart isn't going to make much sense yet until I teach you a quick little acronym, which I'll get to at the end. But you can just kind of file those and keep those handy so that you can refer back to them. I will encourage you to pause the video and copy this stuff down, and I will address these things when I get to them later on in the notes, okay? But just some things for you to get copied down and to start thinking about and being curious about. We also have this last little box here is called Pythagorean Identities, the first 3 identities of very many that we're going to be talking about here. And I want to answer this question and address this in class. What I'm going to do now is just dive into these first couple example problems, okay? So I'll get to a little bit more of an explanation in class, but I want to get to some of the basic stuff here. Okay, this very first problem, find the sine of theta if you're given the cosecant of theta. So this is going to be just a little bit of algebra review. So remember that the sine and the cosecant are reciprocals. So that means what I can do for sine of theta is to flip these, but it's going to involve a little bit of algebra before we do that, okay? So that means that the sine of theta, I'm just going to flip it, don't lose the negative, 2 over radical 12. Okay, you know that you can't leave a radical in the denominator. What I think it's easier to do, hopefully you've recognized that this 12 breaks down, like that radical can be simplified a little bit. It's 4 times 3 and 4 can be square rooted. So another way to write this would be 2 radical 3, because keep in mind that radical 12 is radical 4 times radical 3. Okay, but still we can't leave that stupid radical in the denominator. So what I'm going to do is rationalize it. The 2 is fine, this 2. The 3 is what needs to be rationalized. So that's what I'm going to work with. That gives me negative 2 radical 3 on the top. And 2 times, this just becomes regular 3, which is 6. And then my final answer, this is just some algebra review, like I said. Sorry, that was my phone ringing. This can be reduced, so we get negative radical 3 over 3. A little bit of review for you in algebra. We did a lot of that in algebra 2 last year, maybe with radicals and rationalizing and stuff. But it's not always as simple as simply flipping the fraction. This one involved a lot of algebra. So I know that this and this probably don't look like they have anything in common, but that is what happens sometimes when you have to do reciprocals. Okay, this impossible or possible situation down here, they can be a little bit tricky, but what I will direct your attention to is what we copied down up here. A couple things you need to keep in mind. The sine of theta is always in between -1 and +1, okay? Why is that? We will get into that way later. For right now, just focus on the simple task of just memorizing this thing. Cosine works the same way. It has to be between -1 and 1. Tangent and cotangent do not have any restrictions. Once we get into graphing, you guys will understand a little bit more about this, but the range of tangent and cotangent graphs are -infinity to +infinity. And then secant, since they're reciprocals, the secant is reciprocals of cosine and cosecant is a reciprocal of sine. They have kind of the opposite effect. So it's not in between -1 and 1 like sine is. It's the opposite of that. So the cosecant of theta has to be less than or equal to -1 or greater than or equal to 1. So think about like the outsides versus the insides. And then cosine and secant also go together. So that was a long-winded explanation for how do we do these impossible or possible things. So first of all, what you need to know is that the sine of theta equaling radical 8, well, I think better in decimals. So actually radical 8 is about 2.82 something, and that is way bigger than 1. This is an impossible. Because remember, the sine has to be in between -1 and +1, the sine of theta. So because this is 2.82, that's bigger than 1, which is impossible. Okay? What about tangent over here? Tangent is, wow, that's a huge number, but remember, tangent and cotangent can be anything, so this is possible. There are no restrictions here that we're going to talk about right away with tangent, okay? And then secant, 0.6. So remember that secant has to be either greater than or equal to 1 or less than or equal to -1. So this does not fall into that category. Again, we have another impossible. Okay, so just remember and try and memorize those rules, and that's how you're going to attack those possible or impossible questions. Okay, now we have a different type of question. Suppose that angle theta is in quadrant 2 and we're given the sine. Okay, before you start like thinking or getting confused or doing anything crazy like this, what I like to do is we're given two pieces of information, this and this. I'm going to draw it. Quadrant 2 looks like that. So draw a triangle in quadrant 2. Here's my theta. And the fact that sine is 2/3, remember that the sine is the y value over the r value. So that means I know where the 2 goes. It goes here. And I know that the radius, the r value, is 3. So I have 2/3 of my triangle figured out. And then remember that you can always come up with that third side because of Pythagorean theorem. And it's radical 5 by Pythagorean theorem. Okay, here's the tricky thing is think about this in terms of x's and y's. What you have to remember is that the x value in quadrant 2 is negative. This is really, really important and very commonly forgotten, but don't forget the fact that the x value in quadrant 2 is negative. The y value is still positive because we went up, but because we moved left of the origin, that radical 5 down there that I found using Pythagorean theorem has to have a negative sign with it. It's just like a regular graph. And so from there, now that we have all three sides, go ahead, you guys, fill in all 6 of your trig values. Pause the video and then check with mine. All right, here's what all those look like. The sine, that was kind of a freebie. We were given that one. The cosine, remember, is x over r, and then the tangent is y over x. That needs to be rationalized. Don't lose this negative sign. Make sure that your fraction stays negative. And then keep in mind you can just do the reciprocals. For cosecant, we're just doing the reciprocal of the sine. For cosine, we are doing the reciprocal in order to find secant. That does mean that you need to rationalize that because you can't leave that radical in the bottom. And then remember a trick, when you're doing the reciprocal of this tangent, use the unrationalized fraction, this one, because then you won't have to rationalize again. Okay? I encourage you to try number 4 the same exact way. Pause the video and then check your answer with mine. All right, here's what that one should look like. Very similar to number 3, but in number 4, we are in quadrant 3. So I drew my quadrant and drew my triangle down here in quadrant 3. Remember, you're always drawing your triangle up towards the x-axis, never over to the y-axis. And we're given the tangent here, radical 7 and 3. So just remember that tangent is y over x, so that gives you the y value and the x value in order to do your triangle and figure out your sides. Did you catch the most important part here? In quadrant 3, the x value is negative because we went left. Also, the y value is negative because we went down. So you have to be really, really careful about those negatives. I don't want you to memorize things like, oh, in the third quadrant, the sign is always going to be negative. I want you to just label your triangle with those negative signs. That's a really, really common mistake and a huge thing that a lot of people forget. So keep that in mind. That is why my ratios here all have negative signs. For tangent, that was our freebie. Notice that both the negative signs canceled, and so that's why it became positive. Do the reciprocal of sine to do cosecant, and that needs to be rationalized. Do the reciprocal of cosine to get secant. That does not need to be rationalized because there's no radicals. For tangent, we had to do the reciprocal of this one. It stays positive, and I had to rationalize it. Okay, I do want to skip number 5 and A and B, but I want to go down into number 6, and then we will be donezo, okay? Here is something crazy, and this is a generalization about the signs of the trig functions depending on what quadrant they're in. In quadrant 1, the x and the y are always positive, right? Because the x-axis is positive here and the y-axis is positive here. That means that all functions are going to be positive. So I like to put a giant A near quadrant 1. In quadrant 2, what's different about this is that the x values are always negative. This is the negative x-axis, but the y's are always positive. And so anything that has an x value in it is going to be negative then. And so that means that cosine and tangent are both going to be negative in this quadrant. Or another way of thinking about that is that the sine, since that's the only one that has y and r, which are both positive, is always going to be positive. So the sine is always positive in quadrant 2. And you have to keep in mind that sine and cosecant go together. Okay, quadrant 3, similarly, what we have here is the tangent and the cotangent are positive. Did you catch that up here in number 4? Since both of these were negative, that made our tangent positive, but everything else was negative. That's something for you to think about, and hopefully you're starting to make a couple connections like that. But that means that the tangent in quadrant 3 is always positive. And lastly, in quadrant 4, the cosine is always positive. And keep in mind the reciprocal functions that go with them. So cosine and secant always go together. How do you remember this? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take calculus. That's how I remember it. That's how I was taught it when I was in high school. Yes, I took calculus. Yes, all of you guys are taking calculus. You're in pre-calc now. You are headed towards calc. All students take calculus. So no matter what, in quadrant 1, all of the trig functions are going to be positive. In quadrant 2, sine, and cosecant always goes with sine, is always going to be positive. That means the other ones are negative. In quadrant 3, tangent and cotangent, they always go together. Tangent's always positive down here. That means the rest of them are negative. And the last one, cosine and secant, here are always positive. That means the rest of them are negative. You didn't need to memorize that. In fact, I didn't tell you that when we did these up here. You're able to look at the graph and be able to tell where's my negative signs, which one's positive, whatever, and it works out. But you can check these, given that we were in quadrant 3, with this chart down here, okay? This is going to be really important, and yes, what I like to do in the top of my tests and quizzes is draw the quadrants and label all students take calculus as a reminder. Okay, so that's going to help us do this number 6. Identify the quadrant or quadrants of the angle satisfying the given condition. So here's what my quadrants look like. All students take calculus. And the fact that the first piece of information is that the sine is positive. The sine is positive in this quadrant and in this one, so not these two. The second piece of information we're given is that the cosine is negative. Well, the cosine is positive in this one, so it can't be that. The cosine is negative here because sine is positive. So we are in quadrant 2 for this answer. Very last one, all students take calculus. The cosine being positive, well, the cosine is positive in both of these. Remember, the A stands for all of them are positive in quadrant 1, and the C stands for cosine being positive in quadrant 4. That means we can eliminate these two. And which of those two is the tangent also positive? Well, tangent is negative in quadrant 4, but all of them are positive in quadrant 1. That gives us our answer of quadrant 1. Okay, we're getting into some confusing stuff, you guys. I encourage you to write down what your questions are, bring them to class, talk with your group members, ask me questions. We're getting into a lot of tricky stuff, but if you're staying on top of the videos and using your time in class wisely, I'm sure you're going to be just fine. So, thanks for watching. Bring those questions to class tomorrow. We will finish up the rest of the notes, and then it's review time. Have a great night.